Hello. Today we're going to talk about Topic 4, Section 3, Measures of Central Tendency and Dispersion. Okay. Well, measures of central tendency would be your typical ones that you've been doing since forever. You know, your mean, median, and mode, and range. Well, yeah, we'll get there. So here we have a set of data and the box plots. And notice that if we just looked at the mean, median, mode, and range of these sets of data, that they look identical. So the lesson on the first slide is don't just focus on the stat part, the info. You have to look at the picture. All right? Just looking at them on their own is not enough. You should always look at the picture. All right, so the first measure of central tendency would be your mode. So the mode happens the most. Okay? Mode is the one that happens the most. So you can have more than one mode. That would be bimodal or trimodal if it had 3, and so on. All right. That is if let me be clear with that. That's not something like this where you have, here's your number and here's your frequency, where you have 1, 2, and 3, where 1 happens 4 times, 2 happens 6 times, 3 happens, let's say 2 happens 16 and 3 happens 18, but then 4, 5, 6, 7, 8, all those happen just, a few times. Okay? Just because 2 and 3 happen a whole lot does not make them both modes. This is the only mode. Unless this number 2 happened 18 times as well, then that would be bimodal. Okay? So don't get confused there with, just because they both happened a lot doesn't necessarily mean they're both modes. They both have to be equal for them to both be modes. Okay? Also, if no values are repeated, then there is no mode. Okay? It's possible to have no mode. You would not say the mode is 0. Okay? Because then that's a value. Okay? So you would say no mode or none. All right, the median, we've talked about this one in the last lesson. This had to do with your box and whisker plots, or box plots, and that median was in the middle. Okay, think about driving a car. You don't want to drive over the median because then you would go into oncoming traffic. Because the median is where? In the middle of the road. Okay, so the median number is in the middle of the data. All right, but you have to have the data in order. Okay, you can't just have it haphazardly thrown anywhere and then just pick the middle. That's not how that works. It's got to be in order. Okay, if there is not, if you can't split the data in half, like there's not a middle number, say it's, it's perfectly even set of data, then you have 2 middle numbers and you would average those to find the median. Okay? All right, the measures of central tendency, the mean is the average. Okay, so that's the arithmetic mean. We've done this with arithmetic series. A lot of times you'll see them written as this weird formula and it throws everyone off. You know what this is. That's a sigma, capital sigma, which means sum. So sum of all the values of x and then divide by how many there are. All right, from 1 to whatever, 100 data sets, 1,000,000 data sets, 14 data sets, whatever. Okay, that's the arithmetic mean. That's how you get the average. Okay, what was it? I forget my pun. I don't know. I think it had something to do with mean girls and mean and being average, but it'll come to me later. All right, example 1. So let's find the mean, median, mode visited by the group of students. Okay, so we want to find the mean, median, and mode. Okay, so algebraically, we could just find the average, so we could literally add them all up. So let's get out the calculator. Get rid of that. So the average. So 1 happened 4 times. So 1 times 4 plus 2 happened 6 times plus 4 happened 3 times, plus 5 happened 4 times, plus 7 happened 2 times, plus 10 happened once. Okay, so the sum of all the values is 72. And then the total number of frequencies, let's see, that's 10, 17, 20. Yeah, oh, they said 20 students. So the mean is just 72 divided by 20. So the mean is 3.6. The median is in the middle. Okay, so let's see. We want to find the middle of 20. So you're going to have, let's see. You want to find the 11th, hold on, the 10th plus the 11th and divide by 2. Okay, because there's, all right, for the median, how do I explain this? Okay, there are 20 students. So you want 10 students over here and then 10 students over here. There's no middle, so that would be, you know, your first, second, third, all the way to your 10th. And then here would start the divide of the 11th, 12th. Ooh, I don't know why I wrote 21. 12, da, 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 all the way to 20. Okay, so getting the middle number would be the 10th and the 11th number. So let's find the 10th and 11th number. The 10th number would be a 2. And the 11th number, so 4, 6, that's 10 numbers there, 11, so 13 numbers here, so 11 is 4. Okay, and then we're averaging those two. So that would be 3. So the median is now 3. And the mode is the one that happens the most, so that would be 6, a frequency of 6, so that would be 2. Okay, so that's how you can do it algebraically. You can also use your calculator, so let me show you that. Go to Stat, Edit. Here, I want to clear out my list, so go to the top, hit Clear, Enter, top, Clear, Enter. Okay, so we're going to put the number of countries in the first column, so 1, 2, 4, 5, 7, 10. And then we're going to go and put the frequency in, so 4, 6, 3, 4, 2, and 1. And then we are going to do our calculation. So go to Stat, then go over to Calc, do one variable stats, list 1, so second 1. Frequency is list 2, and then we calculate. The mean is 3.6. Let's see. The median is 3, and then they're not going to tell you the mode because that's pretty obvious to see. Okay, at least I don't think it's on there. Yeah, mode's not on there. Okay. All right, so let's do another one. So why don't you guys try this one? Let's see. You can try putting it into your calculator. And what I would do, all right, I wouldn't type these numbers into my calculator. I would kind of, how should I put this? This one is a little bit different because we have a range of values. All right, it's going to be a little bit harder to estimate the mean, median, mode because we don't have the exact values. We just have, well, those three numbers are somewhere between that. So to estimate, we're going to use the median, okay, or the average of the outsides of each of these. So what I mean by that is instead of putting in the height as a range, we're going to put that middle number, which is 151. Then put 154, 157, 160. I hope you're getting the idea now. What are we at? 69, 172, and 175. Okay. So we go to put it in our calculator. I know, it takes a second. clear everything out. Okay, so 151. I love that I can type this. This is really handy. Okay. Then type in this. 6, 12, 7, 4, 2, 4, 5. Okay. Make sure that the tables line up. Okay. That's very important. And then we can go ahead and run our one variable stats. List 1, list 2, calculate. Okay, so the mean is going to be approximately 161.8. 161.8. Our median is 160. And here we get our mode happens the most is 160. And these are all estimates, right? They're not exact because we don't have the raw data. So we're assuming that this is where they're going to be. Well, roughly. Okay. Okay, so the measures of dispersion is range and your inner quartile range. Okay, so measures of central tendency are mean, median, mode. Dispersion is the spread out. Okay, think of how like you drop marbles and how it disperses on the ground. That's the range, okay, where the spread is. Okay, the range isn't very useful. Okay, it tells us how spread out the data is in general, but the IQR, the inner quartile range, tells us where 50% of the data is. So if we look at this first one, the IQR, knowing that the 50% of the data is most of it, that's pretty spread out. It's kind of hard to guess where it's at. But in the second one, if you know 50% of the data is right in the middle, well, you're getting a lot closer and you're narrowing it down kind of idea. Well, it's one way to look at it. Okay? So the IQR can tell us a little bit more, right? Because again, we know those, how it's chunked into quarters. Okay, so variance and standard deviation. These are big ones, okay? Big part of statistics. So they measure how each variable deviates from that mean, deviates from that average, okay? So the higher the value, the more spread out it is. Okay, so variance and standard deviation are literally almost the same number. The variance is just the standard deviation squared. Literally, look at it. It's sigma, and then this is sigma squared, lowercase, okay? Now, variance is what we do for calculations. Variance is useful when we're dealing with math stuff, and that's later on. Standard deviation is easier to explain. That's how we dumb it down and we talk about how useful it is. Okay? So again, variance is a useful number in the mathematics world, but if we're describing it to other people, we want to use the standard deviation. Okay? So let me explain why. Okay? So, but hold on. Before we get started, let me go back. Here, let me add this. Okay, let's see. Okay, here is your normal distribution. Okay, so think of it like this down here. Okay, start down here. This is our mean. Oh, not writing. Hold on. We've got our mean in the middle. And this is one standard deviation to the right. This is one standard deviation to the left. Okay? So remember, this is standard deviation. 2 standard deviations. 3 standard deviations. Okay? This is one standard deviation to the left. Okay? So we would like most of our data to be near the mean. And in a perfect world, in a normal world, okay, we're going to have 34% roughly to the left in the first standard deviation and 34% to the right. So we have about 68% within one standard deviation, both up and down. Then 95% within the first 2 standard deviations, and 99.7 within the first 3. So this is the first 3 standard deviations. 2 standard deviations, 1 standard deviation. Okay, that means 0.3% is more than 3 standard deviations. Okay, so this is 0.15. This is 0.15, is everything up past those, okay, which is very, very slim possibility, okay? All right, so that's kind of, in a nutshell, what a standard deviation is. Maybe it'll make more sense when I apply it to our sets, okay? So find the variance and standard deviation of the data from set A. Okay, ooh, don't know why set B is right there, so get rid of that. Okay, okay, so how do we find the variance and standard deviation? So I would use my calculator. Yes, there is a formula. It's gross and long, and no one likes using it. So use the calculator. I'm going to clear out my lists. All right, clear them out. Okay, so let's type in the first one. We have 3, 4, 5, 18. There we go. Okay, so then we're going to do the same thing we did before and use our calculator, or go to calc function and do our one variable stats. All right, but now our frequency is just 1. Okay, oh. Why? Okay. There we go. We don't put anything for the frequency list. So now here it shows you that the mean is 15. Okay, right? We got that part. So then the standard deviation, all right, it's not this one. I don't know why they do this. It's the SX. Okay, that's the standard deviation. It's 8.39. Okay, so the standard deviation, what did I just say? 8.39 is, I'm sorry, roughly 8.39. Okay. Oh, what am I doing? And then what else do we need? We need, that's the standard deviation. So then the variance is just that squared. Oh, didn't mean to press that. Okay, so literally, what happened? Okay. We're going to do 8.39 squared. Ideally, you would probably do more, or more decimal places, do better than that, right? So this was the standard deviation. The variance should approximately be 70.39 or 70.4. Okay? All right, so I would definitely use your calculator, but know how to find the variance and the standard deviation. It's essential. Okay? So for this one, you should get the standard deviation is, let's see, approximately 5.80, I believe, and the variance should be 33.64. Okay? All right, so what that tells us, maybe a visual might help you understand what that standard deviation is. So on this data set, we know that the mean is 15. So our mean is 15. And our standard deviation is 8.39. So if we, hold on, it's going to help me if I have my calculator handy. So 15 plus 8.39 is 23.39. So then one standard deviation up is 23.39. And 15 minus 8.39 is, oh, if I can do things correctly. All right, so one standard deviation to the left is 6.61. Okay, so that was one standard deviation. Let's do 2 and then 3. 2 and then 3. I'm trying to make them even, but you know, I do the best I can. So that was 1. So let's do another standard deviation. Add 8.39 both directions. 8.39. This gets us 31.78. Add another 8.39. and this value is 40.17. Keep going down to the left. Negative 1.78. All of these have a difference of 8.39. There's a pattern there. Okay, I'm just getting my values. Okay, most of my data should be around 15, so that's going to be my middle of my bell curve. Then I go down like this. Most of my data should be from 6.61 to 23.39. All right, 68%. 95% is within these values, and then 99.7% are between -10 and 40. All right, that's where most of my data is going to stand, where this is the mean. Okay, so hopefully this makes a little more sense on how I draw my bell curve. That's what I would expect this data set to look like, or any values within, this sample, this population. Okay, example 2, we could do the same thing. So we draw a curve. Our mean is the middle. Remember we said that was 15. 1, 2, 3. 1, 2, 3. Usually the tails are supposed to be very, very tiny, so I did not draw that very well. Hopefully you guys are doing a better job with that. So we want to add 5.80 up and down. So why don't you guys take a minute, pause it, and see if you can find 1, 2, and 3 standard deviations. All right, so hopefully this is what you got for your normal curve, okay, for this data set. All right, let's keep it rolling. Let's do data transformations. So if we add or subtract a value to all of the data in the in our set, the mean will increase or decrease by the same amount, but the deviation will remain the same. Okay, literally, because the standard deviation is how far apart the values are, how it deviates from the mean. And if everything is getting shifted, then it's not shifting from the mean. We're not shifting one value, we're shifting all values. So the mean is changing, but the standard deviation is not. Okay? So if each data point is multiplied or divided by a constant factor, that does change the spread. Okay? So these are the things that we want to do when we multiply or divide by a factor. Okay, all our values. The mean we multiply, the standard deviation is multiplied by the absolute value, so just the positive, and the variance is transformed, but you have to square that value, okay, because again, variance is standard deviation squared. Oh, mouthful. Okay, so example 1. Okay, so what's going to happen to our mean? Remember that value looks like that, or that symbol. All right, so if we're going to change everything, or every value is decreasing by 5, then the mean will also decrease by 5. So the mean is now 6. The standard deviation, okay, remember is this symbol, is not going to change because all we did was subtract. So the standard deviation is going to stay as 2.3. Just that simple. All right, so with the same set of data, a mean of 11, standard deviation of 2.3, blah, blah, every set is multiplied by 4. So what are we going to do when we multiply by 4? Okay, so the mean is also being multiplied. So the mean is going to be 11 times 4, so 44. And our standard deviation, okay, standard deviation, sorry, I like to do all the symbols. Okay, so that is going to be 2.3, also times 4, okay, which is 9.2. There you go. Easy peasy. How simple it is to show your work too, right? Gotta love it. Okay, so hopefully this makes sense. Again, if it doesn't, please talk to me. Stat is weird. I can't say that enough. It takes up most of the IB exam. Please, please, please ask me when things get weird. Okay? All right, I'll see you in class.